Hey everyone, in this video we'll be going over sine and cosine functions and how to identify the amplitude, period, midline, domain, and range. So before you can be able to answer these questions, there's a few things you need to know. So to start, the first thing you want to know is what is the formula that is used to create these cosine and sine equations. And really this formula is applicable to tan, cotangent, secant, and cosecant, and of course cosine and sine. So the equation is y is equal to a cosine or sine b x plus c plus d. So this may look a little daunting at first, but I'll break down what each of these variables, a, b, c, or d, what they mean. So just a heads up, just to reiterate, this equation is applicable to most of the equations that you'll see in trigonometry. So that being cosine, sine, tan, cotangent, secant, and cosecant. So let's talk about what a means. So a, what does the variable a determine? It determines first, so number one, amplitude. Now what is amplitude? Amplitude is essentially just the height that the graph goes past the midline. So it might be easier if I show a graph. So let's draw out just a small graph here. And I apologize if it looks kind of bad. So let's just take that graph. Now, let's just take a point on this graph, and preferably it being a max height point or a midline point, or of course the lowest possible point on the graph, to make it a lot easier to actually determine what the period or amplitude is. So let's take just this point, or actually let's just do this midpoint here. Let's just do it on the x-axis. So from this point, to determine the amplitude, this amplitude is essentially past this midline. So assuming the midline is right here, so that's the middle of the graph, this up to here is the amplitude. So from here all the way down to here. And I'm sorry if that's not even, but it's meant to be even. So no matter where you go on the graph, if you go to the max height and then you trace that down back down to the x-axis, that number is your amplitude. So from this point all the way up, and when you reach that point, it's that distance between the max and the x-axis, or the x-axis and the lowest. So that is the amplitude. Now on a equation, the amplitude is just the a value, and you might want to note that the amplitude can never be negative. So that's very important. On tests, you will see an amplitude and it'll ask whether it's positive or negative, and always pick, and it's the positive one. An amplitude can never be negative because, well, the distance on this graph can't be negative because you're just counting from the x-axis to the max or lowest point. So it's not negative. So that's the a value. Now, one more thing that the a value can determine is, so number two, let's stick with black. So the second thing that the a value can determine is vertical stretch / compression. Now, you might have seen this in earlier units in pre-calculus or algebra 2. So transformations have really just been important throughout most, or if not all, of your math courses so far. So this should not be anything brand new. So now let's look at what our b value is. What does our b value determine? Let's look at b. So the b value helps determine, so it helps find the period. So key word here being helps. So it helps find the period. The b value, you have to make sure that you remember this because it's easy to get confused. The b value is not the period. So the b value is not the period. It helps you find the period after you plug in the b value into a new equation, but the b value is not the period. So you have to remember that even when you're taking from a graph and making the equation, the b value is not the exact period. So now, how do you find the period? To find the period, that's right, finding the period. Now this equation only works for, sine graphs, cosine graphs, secant graphs, and cosecant graphs. So we'll get into those cosecant and secant later on, but for now, this sine and cosine graphs, this only works for them. Cotangent and tangent have a different equation to find the period. So this equation is 2 pi over b. That is our equation. So you would take your b value from the equation and you would plug it into this formula. Then this creates your period. Now that is why oftentimes your period might be a fraction, because 2 pi and you're divided by your b value might not equal a integer. It could be equal to a fraction. It can be anything. So that is why your period, it's okay if your period is a fraction. Don't fret if it is. So that's what our first part of our b value does. Now the second part of our b value goes back to what I said earlier. Every part of the equation determines a transformation. So the b value's transformation is, so let's look at number 2, horizontal. So this determines horizontal stretch / compression. So your a value determines vertical stretch and compression, while your b value determines horizontal stretch and compression. Now let's take a look at our c value. Let's take a look at our c value. So here we have c. Now our c value first determines our right and left shift. So these could also be called horizontal phase shifts. Now, that in itself is a transformation. So the c value directly determines a transformation. So, and remember, if it's in those parentheses, do not be tricked. That becomes, you have to set that x plus c equal to 0, and x is equal to negative c. So don't forget that. It's the same thing in Algebra 1 and Algebra 2, and probably earlier units of pre-calc. Your x plus c, that you have to make that a negative. So don't be tricked by that. So now let's look at our final value, our d value. Our d value is just as easy as the c value. It determines vertical shift. So that would be up and down. So that, remember, the d value, when it's outside of those parentheses, it's just a direct. There's no tricky stuff like the c value, where you have to make it a negative. It's directly, if it's a negative, it's down. If it's a positive, it's up. So that's all you need to know. Those are the basics. And now we can go ahead and solve those practice problems that you saw earlier. So let's go ahead and solve those equations. Let's see. Let's look at the first one. For 1 through 4, identify the amplitude and period. So for number 1, we have y is equal to 3 sine 2x. Now let's go ahead and dissect our equation. Let me move this over here if this helps. Okay. So let's see. Y is equal to 3 sine x. Now we know our a value is at the front. So our a value is up here. So right before that a value is right before that trigonometry sign. So it's either sine, cosine, secant, cosecant, and so on. So it's just before that indicator. So then we have our b value right after that sine or cosine. So it's right after that. And then here's the little bit trickier. You have the x value. So you have x, and usually it's supposed to be plus c and plus d. But in this case, there's no c or d here. So we can assume that c and d are equal to 0. So there's no need to calculate them. And the questions involve period and amplitude. We don't have to use the c and d value. They don't change anything. So what is the amplitude? So remember, the a value directly determines the amplitude. No tricky stuff here. So, and remember, the amplitude can never be negative. So the a value is directly the amplitude, so we can go ahead and fill it out as 3. So it just goes right there. Now let's look at the period. So this is a little bit more difficult. So now remember, the period equation is 2 pi over b. So if you can see it over here, is 2 pi over b is equal to the period. So let's write down 2 pi over b. Now let's go ahead and plug in our b value is equal to, let's write 2 pi over 2 is equal to, the 2's cancel, is equal to pi. So in this case, it became a straight symbol, no fractions, no nothing, but that won't always be the case. So we have just pi. So our first problem is done. Let's look at number 2. Let's look at number 2. We have 5 over 2 cos x over 2. Now immediately we can see that this is our a value, and that's our indicator of what the equation is like. And then we have our period. Now the tricky part here is, that's our b value. So the tricky part here is that the x is on top of the b value. So normally that's not how it looks. But in this case, all this equation is 1 over 2x. So that in problems, that x just goes to the top and it looks like x over 2. But don't be tricked. That's just 5 over 2 cos 1/2 x. And then if there's a c or d, it'll be there. But in this case, there's no c or d, so we can assume they are 0. So since it's 5 over 2, we can assume that's amplitude because that's our a value. Then our b value is, remember, our b value is 1/2 is equal to b, right? Because x over 2, that's just 1 over 2x, and that x belongs to the x plus c plus d, and the 1/2 is just the b. There's no x in that b value. So 1/2 b, so we can just set that into our 2 pi over b equation. We get 2 pi over 1 by 2, and that just becomes 4 pi. So that's just algebra. You just bring it to the top when you're dividing fractions, you swap them, and that'll just become 4 pi. So our period is 4 pi. Let's look at number 3. So you might be getting the hang of this. Let's break down our equation. So we have y equals 3 sine 10x. Now, our 3 is right in front, so our 3 is right in front of that sine or cosine, so we know that's our a value. It's directly in front. Now, what's directly after our sine or cosine is 10, so we can assume that 10 is our b value. Now, in this case, there is no c or d value because it would be x plus something, but in this case, there's no c or d value, so we can assume they are 0. So let's put our amplitude in. Remember, amplitude is directly our a value, so it's 3. Remember, the amplitude can never be negative. And our period comes from our b value. So we have 2 pi over b is equal to 2 pi over 10 2 cancels, and the 10 becomes a 5 because you're dividing 10 by 2, so it'll just become 1 and 5, and that'll be equal to 1 over 5 pi, which is equal to pi over 5. So this is our period here. Pi by 5. Now, here you can see we got 1 by 5 pi, so we just brought that pi to the top because that's the same thing. If you were to expand that 1 over 5 pi, you would just take the pi times the 1 divided by 5, so we can just simplify that and write it as pi over 5. Now for number 4, let's write out what our values are. So we have a, because it's right in front of that indicator here. In this case, it's cosine. And what's right after our cosine is our b value. Now this is a little bit trickier. So right now we see 2x over 3 instead of just 1/3 or just a 1 there. So what happens is that we just take out that x. So what happens if we take out that x from that supposed b value, right? We take out that x, it becomes 2 pi over 3x. So that's our new, that's just our breakdown of 2x over 3. And now we can see that this 2 over 3 is really our b value, and that x belongs to the c plus d, but in this case, there's no c or d value, so we can assume they are both 0. So that 2 over 3 is our b value, so it becomes amplitude is 1/2, and then our period, remember, plug in that 2 pi over b equation, is equal to 2 pi over 2 by 3. We bring this guy and multiply, so it'll become 6 pi over 2, which is just cancel, becomes 3 pi. So our period is 3 pi. So that was relatively simple. And in the next video, we'll cover 5 through 8 and how to find the domain and range.